Okay, everyone, assalamu alaikum. Hello, we are going to start our today's session now. We are done with functions apart from function transformations. In our last session yesterday, we looked at a number of different questions from recent past papers and also, I think, one or two questions from the worksheet, which were relatively more difficult. So as far as functions topic is concerned, we are pretty much done. There's just one concept left, and that's something that was added to the syllabus just a couple of years back, in fact, 3-4 years back. That's function transformations. Okay, so that's what we want to do today. We should be able to discuss almost all the concepts of this topic in this class, and then you can do some practice questions. And tomorrow we will be doing practice questions on function transformations and engine. All right, and then tomorrow we should be done with this whole topic, hopefully, including functions and function transformations. And then on Thursday, we could start the last two topics that we are left with. Not Thursday, I think the next class is going to be on Friday after that. On Friday, we could start one of 𝗣𝗽𝗶𝗶 or circle equations, most likely circle equations, and then we'll do 𝗣𝗶𝗶 next week as well. All right, so that's the plan for the next few days. Now let's start with function transformations for today and see what this is about. Okay. Now just give me a second. I'll just start. Okay, good. So let's begin then. So function transformations, this is another major part of functions. That's what we want to start with. So what different transformations are we going to be talking about? Remember, you've done this topic in O-levels as well, the transformations topic. And in O-levels, there were 4 different types of transformations that you did. You had reflection, translation, rotation, and enlargement, right? Those were the 4 different transformations that you did in O-levels. Now, in A-levels as well, you need to know some of those transformations, not all of them. So we will not need rotation as such and also not enlargement. But we will still need to know about reflection and translation. All right. So those are the 2 types of transformations that you still need to know about. Okay. So reflection and translation, those 2 transformations you need to remember from O-levels as well. And then there's one new type of transformation that you have in A-levels, and that is stretch. All right. So we have reflection, we have translation, and stretch. These are 3 different transformations that you need to know about. Okay. Now let's start with reflection first of all. So I've just copied some diagrams here to help us understand these different transformations. Let's start with reflection first of all. Now you need to be able to do these transformations on a graph. That's one thing. And you need to be able to describe these transformations. Now, as far as reflection is concerned, there are only 2 types of reflection that you need to know about in A-levels, in functions in particular. There are only 2 types of reflections. One is reflection in x-axis, and the other is reflection in y-axis. All right. So these are the only 2 transformations that you would need to know about as far as function transformations is concerned. Okay. So first of all, let's say we have a triangle like this. Now, let's try to understand what it would mean to reflect this triangle in the x-axis and what it would mean to reflect this triangle in the y-axis. I think it's something that's quite straightforward. So I'm going to do it very quickly. So first of all, one type of reflection that we could have could be reflection with x-axis as the line of reflection. Reflection with x-axis as the line of reflection. Or you could say it's reflection in x-axis. That's also okay. So another way to say the same thing could be reflection in x-axis. But now the preposition here is really important. You can't say reflection with x-axis or along x-axis, right? Or on x-axis. All of them are not going to be acceptable. So in order to be very clear, I would say this is what you should do. Write the word reflection and then say x-axis is the line of reflection. Or if you want to write it in short, this could be another way. You could say this is reflection in x-axis. Any other word apart from in here is not going to be acceptable. So if you think you might make this error of using something else other than in here, this is the safer way of describing this. Write reflection and write down the line of reflection. Okay. So these are both ways to describe this. Now, how would we do this transformation on this figure? Reflection in x-axis. Now, all that happens is you look at the distance of each point from the x-axis. Remember, when we talk about the distance of a point from a line, we always talk about perpendicular distance. So if you have to reflect A, for instance, you would look at the distance of A from this x-axis. That's 3 units. When it's reflected, it's going to go on the other side, 3 units down, and it's going to be here. That's A dash. Similarly, B dash is 4 units up. It's going to go 4 units down, and that's going to be here. And then you have C. C is going to go here, C dash, and the reflected figure is going to become like this. This is the diagram that you get when you reflect it in the x-axis. All right, so that's one type of reflection. And then the other type of reflection that you need to know about is reflection in y-axis. All right, these are the only two reflections that we will be talking about. So now we have reflection in y-axis instead. So how could you describe this? You could say reflection with y-axis as the line of reflection, or you could say reflection in y-axis. Now, how would that work? If this is the diagram, if you have to reflect it in y-axis, all you have to do is look at the distance of each point from the y-axis and take it the same distance on the other side. So this point B is going to go here. Point A will go here. This is A double dash. And point C is going to be here. And that is your reflected triangle. Okay, so that's how reflection works. All of you are familiar with this from O-levels as well. There's nothing new as such here. All right, you need to be able to reflect diagrams like this. Now, there's another name that we will be using for these reflections, although when you're describing reflection, this is what you would say, reflection in x-axis or reflection in y-axis. But the first type here, we could also call this, when you have reflection in x-axis, we could also call this vertical reflection. And when you have reflection in y-axis, we could actually call this horizontal reflection. Now, let me explain what that means. Horizontal transformation and vertical transformation. Horizontal basically means that your diagram, that your points are moving horizontally. So, and vertical transformation means your points are moving vertically. So if you reflect in x-axis, for instance, if you reflect in x-axis, what happens to the points? The points that are above the x-axis, they go down. If there was any point below the x-axis, that will go up. So the movement of points is vertical. The graph is moving, the diagram is moving vertically. It's moving up or down. So when you have reflection in x-axis, we call that this is vertical reflection. Okay, we say this is vertical reflection. And if the line of reflection is y-axis, what happens in that case is The points on the left side, they move to the right. The points on the right side, they move to the left. So we could call this horizontal reflection. Now, this terminology is going to become important when we talk about function transformations uh, after 10, 15 minutes. In order to, you need to be able to differentiate what is a horizontal transformation and what's a vertical transformation. In horizontal transformations, points move horizontally. In vertical transformations, points move vertically. Okay. Now, this is the first type of transformation that you have. Now, the second type of transformation that you need to know about is translation. That's the second type of transformation. Now, let's say you had a transformation like this. First of all, you want to translate this diagram by 0 minus 2, or let's say 0 minus 3. Now, what does this vector mean? Remember this? The first number represents the x component of translation. The second number represents the y component of the translation. So 0 means horizontally, you don't have to move at all. Minus 3 means you have to move 3 units down. So the diagram basically moves 3 units downwards. So where does this go? A point is going to come here, B is going to come here, and C is going to be here. And the diagram is going to look something like this. This is the translated triangle ABC when you have this vector 0 and minus 3. All right. So what happens in translation? The diagram moves from one point to another. It shifts from one point to another. So in this case, this was a vertical translation. The movement was vertical. All right. So this is a vertical translation. You could have another translation that maybe looks like this. Let's say you have a translation for 0. What does that mean? 4 is a positive number. That means you have to move right. So 4 units right. And what about vertically? Vertically, you don't have to move at all. So you have to move 4 units right. So the diagram moves 4 units to the right. A point is going to go here. B is going to be here, and C is going to be here. And the translated figure is going to look like this. This is a horizontal translation. The diagram is moving horizontally. All right. This is also something that could happen. Now, what if I told you this diagram basically move to some point here, let's say. Can you figure out what transformation this is? What translation would this be? Any idea? What would be the translation? 1 over 4? Well, first of all, we don't write it as a fraction. It's not 1 over, it's a vector. So there's one number here and minus. Minus 1. So horizontally, how much are we moving horizontally? Look at one point at a time. Look at point A, for instance. Where is this point going? This point is going here. So that's
minus
1 unit.
Minus
1
and
and 5. Are you sure? Think again. So point A is going minus 1, 1 unit to the left. So we say it's minus 1. And how much up is it going? 1, 2, 3, 4. It's going 4 units up. So it's minus 1 and 4. All right. So the translation vector here is minus 1 and 4. Does that make sense? So you're going 1 unit left and 4 units up. Now, given a vector, you should be able to draw the diagram. And given a diagram, you should be able to figure out what transformation is happening. In this case, the transformation is minus 1, 4. Now, the first type that I wrote here, this was horizontal translation because the movement of graph was horizontal. Now the second one was vertical. What about the last one? This is both. This is both horizontal and vertical, right? Because the movement is both, sorry, the other way around, right? This was vertical, this was horizontal. The first one was vertical, the second was horizontal, and the last one, this is both. It's both horizontal and vertical, all right? This is how translation works. Now in translation, how do you describe a translation? In order to describe a translation, you have to make sure that you always write a vector. Always write a vector like this. You cannot describe this in words. You can't say that the diagram is moving this many units left or this many units up or down. It's necessary for you to write down the vector. Okay? Otherwise, you will not get marks for describing the transformation. You always have to write down the translation vector. That's always necessary. Okay? So that's about translation. Now, these are two transformations that you know about from O-levels already. There's nothing that's new about these. This transformation is new for you. Stretch. Let's think about stretch. How can we stretch any diagram? Now, we'll just focus on one of those diagrams for now. I'll just erase this other one. Focus on this diagram, A, B, and C. Now, what does stretch mean? Let's try to understand that. Now, in order to understand stretch, let me remind you about what we did in O-level transformations when we did enlargement. Remember that? How did you use to enlarge diagrams? So for instance, ABC, if this was the triangle that we're talking about, if you had to enlarge this triangle, let's say you had to enlarge it. You have to do enlargement with scale factor 3 and 2,0 as the center of enlargement. If you had to do this enlargement with scale factor 3 and 2,0 as the center of enlargement, how would you do this? Point 2,0 is here, right? This point here. This is the point of reference. This is the invariant point, center of enlargement. The way to do enlargement was you used to measure the distance of each point from the center of enlargement, and you would multiply that distance by 3, right? That whatever the scale factor is. In this case, the scale factor is 3. So what would the enlarged diagram look like? This point A would go like this. This is one box diagonally. This is going to go 2, 3 boxes here. This is A dash. Okay, point A will go here if you were to do enlargement. What about B? It's 1 unit right, 2 units up. So now it will go 3 units right and 6 units up. So maybe somewhere around here. It's going to go right here. This is going to be point B dash. And similarly, C, it's 2 units right and 1 unit up right now. It's going to go here and maybe somewhere around here. It's going out of the diagram, but you get the idea. This is C dash. So the diagram, the enlarged diagram would look something like this. This is how enlargement used to look like. Now, what used to happen in enlargement, whatever the scale factor was, the length of this diagram would change by that factor. So for instance, the length AC was 3 units earlier. Now it has become 9 units. Whatever the length of AB was earlier, now it would be 3 times that. And whatever the length of BC was earlier, now it would be 3 times that. So every single side of this diagram gets multiplied by 3. And your whole figure is enlarged like this, right? That's how you used to do enlargement. You used to have a center of enlargement, a point. And from that point, you used to measure distance that, okay, whatever is the distance from the center of enlargement initially, that will get multiplied by the scale factor. Now, the idea of stretch is kind of similar. Now that you remember enlargement, let's try to think about what stretch looks like. Now, you won't have to do enlargement in A-levels, but in order to understand stretch, I just wanted to remind you about that, because now we could refer to that enlargement concept to understand stretch as well. Let me just erase this diagram first. So we have this triangle ABC. And now let's say we want to stretch ABC along y-axis or you could also say vertically. Stretch vertically, that means along y-axis with scale factor, let's say 3. So earlier we did enlargement. Now we're saying, how do we stretch this diagram by a scale factor of 3 in the vertical direction? All right. Now, vertical stretch means the movement of the graph has to be vertical. Okay. The movement of the graph, that has to be vertical. Now, this is going to be your reference line. Since you want to move graph vertically, x-axis is going to be your line of reference now. So in enlargement, just like you used to have a point of reference, the center of enlargement, in in stretch, you have a line as from which you're going to be measuring distance. In enlargement, you used to measure distance from a point. In stretch, you measure distance from a line instead. So let's say this is the line that we're talking about. You have to measure distance from this line, from the x-axis, and you have to stretch this vertically. By a scale factor of 3, how would it work? This point A, where is this point A going to go? It's 1 unit from this line right now. It will go 3 units from the line. So it's 1 unit at this point. 1 into 3, it goes to 3. The point A is going to go here. Right? Its distance initially was 1. That gets multiplied by 3. And it goes to this point A dash. What about B? Point B is 2 units away from this line. Where does this point go? 2 times 3, this point goes to 6. And B dash is going to be here. And similarly, C, this is 1 unit away from the line. This goes 3 units away now. And the point C dash is going to be here. Okay. And now this is what the stretched diagram looks like. This is the stretched triangle ABC. Now you see the size of the triangle is changing, right? It's bigger than the previous triangle. However, it's not exactly enlarged because not all sides are changing. You can see the length AC was 3 units earlier. It's still 3 units. The height was 1 unit earlier. The height is now 3 units. We call this a stretch because the diagram is basically stretched in one direction. It's increasing in size in one direction, but not in the other direction. That's why it's called a stretch. All right. So this is a vertical stretch. The diagram has stretched vertically by a scale factor of 3. Does that make sense? You can see the movement will only be on one side. So horizontally, there's no change in the width of the triangle, but vertically, you can see the height has changed by 3 units. Make sense? Any questions on this?
No, sir.
Now you could also have horizontal stretch. Now in horizontal stretch, you would be measuring distance from the y-axis. Now let's try a horizontal stretch. Now we want to stretch horizontally. That means along x-axis. The direction of stretch is along x-axis. So stretch horizontally. That means along x-axis with scale factor, let's say now we have -2. Now you could have a scale factor of negative as well. So let's say we have -2 as the scale factor. Now remember in enlargement, what used to happen with negative scale factors? Does anyone remember that? If this was the center of enlargement and you had a triangle here and the scale factor was -2, what would happen? Where would this diagram go? Anyone remembers O-level transformations? Have you forgotten everything? With a negative scale factor, what used to happen was, if this was 1 unit on this side, negative means it would go to the other side of the center of enlargement. It will go 1 and 2 right here. So this point, let's call this A, that's going to be here. And similarly, whatever is this distance, it's going to go double that distance in the other direction here. And then similarly, this point is going to go somewhere around here. And the enlarged diagram would look like this. It will be on the other side of the center of enlargement. Okay, it will be on the other side of the center of enlargement like this. The same happens in stretch. If you have a negative scale factor and you want to stretch this horizontally, that means along x-axis, and the scale factor is -2. Since you want to stretch it horizontally, you're going to measure distance from the y-axis, right? You're going to measure distance from the y-axis and see, for instance, this is the triangle. Let's say we have this triangle PQR. This is the triangle that we have. We want to stretch this triangle horizontally with scale factor -2. Now, let's start with this point P first of all. Where does this point P go? What's the distance of P from the y-axis? It's 0. 0 multiplied by -2, it's still going to be 0. So the point P is going to stay there. That is not going to change. Just like an enlargement, if you had a point on the center of enlargement, that would not change. That would stay there. So if you have a point on the y-axis here, that is going to remain unchanged. Okay, so the point on the y-axis, P, that remains unchanged. What about R? Now, R is 1 unit on the right side. When you stretch it horizontally by a scale factor of -2, it's going to go 2 units on the left side. So it's 1 unit on the right now. It will go 2 units to the left. So the point R is going to go in place of this point Q here on the left side. And similarly, point Q, this is 2 units on the left side. The scale factor is -2, so it should be now 4 units, but on the other side. So 4 units on the other side, it's going to become this point here, Q dash. And what does your stretched triangle look like now? It's going to look something like this. This is going to be the stretched triangle with a scale factor of -2. Okay, that's the scale factor of -2. Does that make sense to everyone? What happens with this when a scale factor is negative? The diagram goes on the other side of the axis. Make sense?
Okay.
Yes.
Can you repeat the R?
Repeat what?
R.
Repeat R? Okay. Okay, so R was initially here, right? It was 1 unit on the right side. Where does it go after the stretch? It's 1 unit on the right. The scale factor is -2. So whatever this point is, its x coordinate gets multiplied with -2. It goes on the other side. So it's 1 unit on the right side. It goes 2 units on the left instead. Okay, so our point goes on the left side like this. This is 1 unit on the right. It goes 2 units to the left here.
So
Make
we
sense?
are measuring from the line of reflection.
It's not called the line of reflection. If you want to call it something, we would call this invariant line. This is the y-axis. When you are moving horizontally, Y-axis is the line of reference. It's called the invariant line. You're going to measure distance from the y-axis while we are moving horizontally. If you're moving vertically, you will measure distance from the x-axis. So depending on whether you're moving horizontally or vertically, you'll be measuring distance from one of these two axes. Is that okay?
Yes, sir.
So they will sometimes ask you to draw a transformed diagram in the exam. This is how you would do that transformation. Okay. Now you might not always get triangles, but it could be some other shape. But how does transformation work? You have to look at one point at a time. So you're looking at one point at a time, basically. So these are the points P, Q, and R. We're just looking at those points. Where does this point P go? That stays there. Where does the point R go? It's 1 unit on the right side. This goes 2 units to the left side. So you have to be able to transform one point at a time. Similarly, Q was 2 units to the left. Now it goes 4 units on the right side. So depending on which side of the line the point is on, initially it goes on the other side, and its distance from that y-axis becomes twice as it was before. Make sense? So that's how stretch works. Now, sometimes what happens is you have a stretched diagram given and you have to figure out what stretch that is. Now, let me show you an example on that. So let's say you had something like this. So just focus on this diagram. What do you think? If you have to go from the triangle, from this figure ABC, it's not exactly a triangle now, from this figure ABC to the one in orange, what transformation do you think has happened here? How would you describe this transformation? Any idea?
A stretch by scale factor of 1/2.
Stretch by scale factor 1/2. So that's very good, but you also have to tell the direction. Is it vertical stretch or horizontal stretch?
Vertical.
This is vertical stretch because the movement of the graph is vertical. So you would either say it's a vertical stretch, or you could say it's a stretch along y-axis. Any of these two phrases is going to work. Stretch along y-axis. What about the scale factor? The distance of this point C, for instance, was 2 units initially. After transformation, it becomes 1 unit. So distance is becoming half of what it was before. So the scale factor, therefore, is 1/2. All right, that's the scale factor. That's how you would describe this transformation. Make sense? Now let's look at the next one. Let's say we have this triangle PQR, and this goes to this triangle P-Q-R'. How would you describe this transformation? Any idea?
Horizontal with a factor -3.
Horizontal stretch with a factor of -3. So that's what's happening here. Let's write it down. We would say this is a horizontal stretch. Or you could say it's a stretch along x-axis with scale factor -3. How do you figure that out? Horizontally, the distance was 1 unit earlier. Let's talk about point P, for instance. It was 1 unit. Now it's 3 units. So it should be multiplied by 3. But since it's on the other side of the y-axis now, we say the scale factor should be negative. So the scale factor is -3. Okay, so given a diagram like this, you should be able to figure out what transformation it is. Okay. So these are the 6 transformations that you need to know about. Let me summarize all of them now. So there are 6 transformations in total. that you have to know about. You have some transformations that are vertical. You have some that are horizontal. And you have reflection. And you have translation. And then finally, you've got stretch. These are 3 different 3 into 2, 6 different types of transformations that you need to know about. You need to be able to figure out what transformation is applying in what circumstance and how to describe it. Now, using the correct terminology while describing these transformations is extremely important. So let me write down the terminology, the phrases that you will be using to describe these transformations. First of all, we've got reflection. Okay, so first of all, we have reflection. How are we going to describe reflection? In order to describe reflection, you would say, if it's a vertical reflection, what does that mean? The graph is moving vertically, upwards or downwards. In that case, you would say it's a reflection with x-axis as line of reflection. So when describing a reflection, you have to write down the line of reflection. It'll either be the x-axis or the y-axis. Those are the only 2 reflections you have in your syllabus as far as transformations is concerned. What would a horizontal reflection mean? That the graph is moving horizontally, right? And you would say, this is a reflection with y-axis is the line of reflection, because when y-axis is the line of reflection, the points on the left side move to the right, the points on the right side move to the left, right? So the movement is horizontal. So that's why we say line of reflection is y-axis in that case. Then you could have translation. When you have translation, when you have vertical translation, you always have to write down a vector for that. Okay, a vector for that. So when you have vertical transformation, vertical translation, the horizontal component is going to be 0. And there's going to be some value in the vertical component. When you have horizontal translation, in that case, there's going to be some number there in the x component and 0 as the y component. Writing down this vector is going to be important. This is how you describe translations. Okay. And then finally, you have stretch. When you have vertical stretch, you could either write it as vertical stretch, that is going to be acceptable. In reflection, that's not acceptable. In reflection, you have to write down the line of reflection. In stretch, you could say it's a vertical stretch. That could be one possible description. Or you could say it's a stretch along y-axis, Or you could say it's a stretch parallel to y-axis. So any of these 3 descriptions would work to describe the stretch, along with the scale factor. So you would say either it's a vertical stretch or stretch along y-axis or stretch parallel to y-axis. And then you would say the scale factor that you have in that case. So you could say with scale factor, whatever that number is, you would write that here. Similarly, if you had to describe a horizontal stretch, the description for that is going to look like this. This is how you're going to describe a horizontal stretch. You could write horizontal stretch, that's acceptable. Or you could write it's a stretch along x-axis, or it's a stretch along stretch parallel to x-axis. All of those descriptions are acceptable. Now, this is important. This is the exact description you have to use. Do not change it. Do not change the prepositions even. So if this is stretch along y-axis, if you say stretch in y-axis here, that would not make sense. Okay, or on y-axis, again, that would not make sense. So it has to be exactly what I've written here. Any of these different options that I've written, you can use any of them, but not anything apart from these. Okay, these are the exact descriptions you have to use. Okay, otherwise you lose marks in this case. Okay, they're very particular about the exact words you're using in your descriptions. And also, in stretch in particular, this is acceptable, this is acceptable, this is acceptable. All of these three descriptions are acceptable along with the scale factor. So you have to write scale factor and one of those three phrases. But then just write one of them. Either write it's a vertical stretch, or write it's a stretch along y-axis, or write it's a stretch parallel to y-axis. Don't write multiple, because if you write multiple, then all of them have to be correct. So it's not helpful to write multiple. If you write one, if you write description as vertical stretch and then you also write it's a stretch along x-axis, you're going to lose marks. Okay, it's not that the examiner would consider that one of them is correct, so you're not going to get marks for that. If you write multiple descriptions, then every single one of them has to be correct. So there's no point of writing multiple descriptions. Just write the one that you're sure about. Use any one of these three options. So for stretch, if it's a vertical stretch, for instance, either write it's a vertical stretch with scale factor this, or write it's a stretch along y-axis with scale factor this, or write it's a stretch parallel to y-axis with scale factor this. One of these three is going to be enough. Is that clear to everyone? Any problem with this? Any questions?
No, sir.
No? Okay, so now that we have understood these basics, how is all of this connected to functions? What are function transformations? That is what we want to understand next. So let's talk about function transformations, how all of this relates to functions. Okay, now understanding those transformations was important so that we can understand now how they are now connected to function transformations. Now we've done this before in a way in trigonometry as well, if you remember. So I'll be kind of referring to that as well. Remember trigonometric graphs? We talked about this vertical transformations of sine, cos, and tan, right? And we talked about horizontal transformations of sine, cos, and tan. At that point, I just asked you to write these down, that this is a stretch, this is a reflection, this is a translation. And we instead talked about amplitude of a function, baseline of a function, whether the graph is moving up or down, right? But now we have to use the language of transformations here. Okay, that's the language that we want to use instead. But it's exactly the same idea that we did in functions in trigonometry earlier as well. Now let me show you this using Desmos first. And that will help you understand this well. Let's say we have a function like this. We have a function f of x, and that equals x squared minus 2 times x. Now, this is what the graph of this function looks like. Okay, it's a quadratic function, x squared minus 2x. This is what the graph looks like, right? It's a U-shaped graph. Now, if I were to change something to this graph, so let's say we have f of x here. If I were to add something to this whole function, so basically instead of x squared minus 2x, if I were to do x squared minus 2x plus 3. So what I'm doing is I'm adding something to the whole function. So I'm adding something to f of x. If I do plus 3 here, what do you think is going to happen to the graph when we do this? F of x plus 3.
It will shift 3 spaces up.
It'll shift 3 units up, right? F of x plus 3, f of x is y, right? So you're adding 3 units to the y coordinates. You're adding 3 units to the y coordinates. So every single point on the graph, the y coordinate of that changes by 3 units, it moves 3 units up. So the graph is going to look like this. You see this blue graph? This is the transformed graph. Every point on the graph has moved 3 units up. Okay? That's called vertical translation. The graph is moved 3 units up in this case. Make sense? So what type of transformation is this? This is translation. F of x plus 3, we are moving 2 units up, 3 units up, sorry. If we had negative here, if we had negative 5 here, for instance, what happens in that case? The graph moves 5 units down. So when you add or subtract something outside the function, the graph moves vertically up or down. Okay? It's a translation. When you add or subtract something outside the function, it's a vertical translation by that many units. Now let's change something else. Let's say we multiply this whole function by negative. We multiply this whole function by a minus sign. What happens in that case? The whole thing is multiplied by negative. So it becomes minus x squared plus 2x. All right. What will happen to this function? So remember, f of x means y. We are multiplying negative minus 1 with f of x. Every y coordinate is going to become, the sign of every y coordinate is going to change. It's going to flip. If the y coordinate was negative at some point, it will become positive. If it was positive, it becomes negative. So the points above the x-axis, they're going to move down, and the points below the x-axis, they will move up, and the graph will be reflected in the x-axis like this. This is called vertical reflection because the movement of the graph is vertical. The point where y was equal to 1, where y was equal to minus 1, now it's y equal to 1, right? So it's a reflection like this. Does that make sense? All right?
Yeah, yes, sir.
This is vertical reflection. Reflection in the line x-axis. And then finally, we could have something like this. Inside the, outside the function, we could have some number multiplying. So let's say we multiply this by 3, let's say. Okay, we multiply this by 3, like this. 3f of x. Now what happens in this case? Every y coordinate is going to get multiplied by 3. So it's a vertical stretch by a scale factor of 3. Stretch along y-axis by a factor of 3. What happens is, let me show this to you here. The distance of each point from the x-axis is going to get multiplied by 3. So for example, this point here, this was 1 unit. This is going to go 3 units away. It's going to come here. The point that was at 0, that's going to remain there because 0 multiplied by 0, it's still 0. And the points that were above somewhere, so let's say this point here, it was at 3, this would go to 9 somewhere above there. So the graph is going to look something like this. This and this. This is the stretched graph, vertical stretch by a scale factor of 3. Now, if I were to use Desmos for this now, this is what the graph would look like. 3f of x. The distance of each point from the x-axis has multiplied by 3. So this point was earlier 1 unit away, now it's 3 units away. If I were to consider another point here, This one, for instance, or let me actually just mark up. This is well, yeah, now it should be visible. So this point that was at 3 earlier, the y coordinate was 3, that point goes to 9, right? 3 goes to 9. Similarly, this 3, this also goes to this 9. So every point is getting multiplied by 3 like this. The y coordinate of that is getting multiplied by 3. Does that make sense? So when you multiply by a number outside the function, it's a vertical stretch like this. So there are 3 types of transformations that we can have vertically. These are called vertical transformations. Let me just summarize all of that now. So one type of transformations that we are going to have are vertical transformations. Let me write that down. Vertical transformations. Now in vertical transformations, what happens is the graph moves vertically. It moves up or down, right? The graph moves vertically. When the graph moves vertically, what that means is only the y coordinates are going to change. The x coordinates remain the same because the movement is vertical. The points on the graph, only their y coordinates are going to change. Only the y coordinates change. The x coordinates do not change. All right. And some operations are applied outside the whole function. Now, let me show you what that means. So if we have a function f of x, whatever we are doing is outside f of x. In vertical transformations, outside f of x, we might, for example, add or subtract something outside f of x plus minus some number, right? Plus minus, let's say b. We could multiply f of x by some number, let's say a into f of x. We could multiply f of x by the minus sign. These are the 3 things that can happen. All right, something happens outside the function. So in the first case, you have translation. In the second case, you have stretch. In this case, you have reflection. So these are the three different things that can happen in this case. Make sense? Now, if I were to summarize all of those 3 transformations that can happen using function notation, you can say, if we have a function f of x, with f of x, you can do 3 things outside. You can either multiply by a number outside, or you can add or subtract something outside, or you can multiply by the negative sign outside. These are 3 things that can happen. Okay. All of these are vertical transformations. All of these are vertical transformations because something is happening outside the whole function. Okay. Now, when you multiply by the negative sign, what you have is a reflection, right? It's a vertical reflection, of course. How do you describe reflection? You would say, when it's a vertical reflection, x-axis is the line of reflection. Now here, it's important to write down the line of reflection. That is the important part of the description. You would say it's a reflection with x-axis as the line of reflection. And what happens with the points on the graph in this case is any point xy on the graph, when you reflect it in x-axis, its x coordinate is going to remain the same. Remember, it's a vertical transformation. So the x coordinates do not change. Only the y coordinates change. Whatever the y coordinate was earlier, now it's going to become negative of that. Okay. So if it was a positive number, it would become negative. If it was a negative number, it would become positive. So xy becomes x minus y. All right, xy becomes x minus y. Make sense? Then you have reflection, stretch. That's the second transformation that we got here. A. When you multiply by a number, you have stretch. Okay. Now, in this case, you can say it's a vertical stretch. Now, in this case, you can also describe it like this. You can say this is a vertical stretch. And that will be an appropriate description. You can say it's a vertical stretch with scale factor A. That's the scale factor. Scale factor is A. Or you could use those other descriptions as well. You could say it's a stretch along y-axis or parallel to y-axis. All of those descriptions would also be acceptable. Let me actually just write this down first. What happens to x, y coordinates in this case? X coordinates remain the same. They do not change. What happens to the y coordinate? Whatever the y coordinate was earlier, it gets multiplied by a. So it becomes a times y now. Right? That's what the stretched coordinates look like. Now, in this case, you could use other descriptions as well. You could use, for instance, stretch. Instead of vertical stretch, you could use stretch along y-axis. That will be acceptable. And you could also use stretch parallel to y-axis. That's also acceptable. In both cases, of course, you have to write down the scale factor with that. That is important. Okay. Then finally, you got translation. What's translation? Plus minus b. When you add or subtract something outside the function, that's a vertical translation. So this becomes, this is a vertical translation. And in translation, what you have to do is, you've got to write down the vector, right? In this case, writing down the vector is going to be necessary. Okay. So if it's a translation, you would say it's a translation with vector 0 because there's no change in the x direction. In the y direction, whatever that number is, that's going to be what you have here. If you have plus b, that would mean the graph is moving up. If it's minus b, that will mean the graph is moving down. Is that okay? And in this case, if you had x, y coordinates, what happens to them? X coordinate remains the same. And the y coordinate, you have b added or subtracted depending on whatever that number is. This is what the coordinates end up being. So this is the summary of the vertical transformations that we have. Any problem with this?
No, sir.
No, sir.
Okay. Okay, so that's what happens in vertical transformations. All right. Let's talk about horizontal transformations now. What happens in horizontal transformations? Now, in horizontal transformations, something changes inside the function. Okay. Now, let me just copy all of this. So now we're talking about horizontal transformations. Now, they're slightly more tricky because they're a bit counterintuitive. We talked about that in trigonometry earlier as well. Let's talk about them again. Horizontal transformations. Now, in horizontal transformations, something happens inside f of x. Let me write that down here. Horizontal transformations. In this case, the graph moves horizontally. The graph moves horizontally. So the movement of the graph is horizontal, okay? Only the x coordinates change, and you have some operations applied inside the function f of x. That means something changes with x. You add something or subtract something to x, you multiply x by something, or you multiply x by a negative sign. All right, so this is what happens in horizontal transformations. Now let's try to look at what happens in each of these cases when we do horizontal transformations on this on this graph. Let's see how this graph is going to change. First of all, let's say we have f of minus x now. So now what we're doing is we're multiplying by the negative sign inside the function. So if instead of f of x, we're saying it's f of minus x. All right, so we've got something inside the function. Okay, this is the reflection. This is a horizontal reflection. So the graph is going to move horizontally. The line of reflection is going to be y-axis. You can try that. This is what you get, because whatever the x coordinate was earlier, when you apply this transformation, it gets multiplied with -1. So if it was at 2 earlier, it goes to -2. So the points on the right, they go to the left. The points on the left, they go to the right. Okay. So you can see this point here, for instance, this had x coordinate 2. Now it becomes -2. This point had x coordinate -1 earlier. Now it becomes +1. So the x coordinates get multiplied by -1. So it's a reflection with y-axis as the line of reflection. That is what happens in this case. Okay, so when you multiply by negative sign inside, it's a reflection in y-axis. It's called horizontal reflection. Now, what happens if we add or subtract something inside? So let's say we do f of x plus 3. What happens in this case? F of x plus 3. What happens to the graph? What type of transformation is this, first of all? Translation, reflection, or stretch?
Moves 3 boxes to the right.
It's translation, and you're saying it moves 3 units to the right. So using that terminology is important. Remember, you have to use the word translation. You can't write that it's moving right or moving left or shifting right or shifting left. Using the word translation is important, otherwise you lose marks. Okay, so you say this is translation. Now, what type of translation? Does the graph move to the right or left?
Right.
Right? It's x plus 3, so it appears like it should move to the right. But let's see what happens. The graph actually moves to the left. It does not move to the right. It actually moves to the left instead. We talked about this in trigonometry as well. Let me just quickly explain that to you. Why does the graph move to the left like this? Let's understand this. So think about a point, for instance, where x equals 0. Or let me actually write this like this. You have one function f of x, and the other function is f of x plus 3. These are the two functions that you have, f of x and f of x plus 3. All right. Now, in the first function, if you wanted f of 0, for instance, right, f of 0, what value of x would you have to input there? X equal to 0. X equal to 0 would give you f of 0. How could you get that same value f of 0 from f of x plus 3? How could you get that same value from f of x plus 3? What value of x would you need to input in f of x plus 3 to get f of 0? You would want x plus 3 to be equal to 0. For that to be 0, the value of x that we would have to input here is going to be -3. So that means the point that we were getting at 0 earlier, now we're going to get that same value of y, the same value of f of x at -3. So you can see on the graph, the point at 0, this actually goes to -3. So the value that we were getting at x equal to 0 earlier, now we get that same value at x equals -3. Similarly, think of another value of x here on the graph. So let's say we have this value, x equal to 2. At x equal to 2, the function f of x would give you f of 2. How could you get f of 2 from the second function, from f of x plus 3? What value of x would you need to input there to get f of 2? You would need to input x equal to -1, right? Because -1 plus 3, that's going to give you 2 inside. So that's f of 2. So the value that you were getting at x equals 2 earlier, now you get that same value at x equals -1. So the point at 2 on the graph, that basically moves to -1 like this. This goes to -1. So every single point on the graph is actually going to move 3 units to the left. So if you have x plus 3 inside, what happens to the graph is it moves to the left. So in horizontal transformations, we discussed this earlier, it's a bit counterintuitive. You just need to remember it's the opposite of what it looks like. F of x plus 3 would mean the graph moves to the left. If it was f of x minus something, let's say -5, the graph would move to the right. So plus means left here, minus means right. Is that okay? So in horizontal transformations, it works the other way around. Any problem with this?
No,
Make
sir.
sense? And then finally, if we multiply by something inside, let's say we multiply by 2 times x. If we multiply x by 2, so that's going to be a stretch. Now it looks like it should be a stretch with a scale factor of 2, but again, it's horizontal. It's the opposite. The scale factor here is going to be 1/2, reciprocal of that. Now, how does that work? The same logic works here as well. Let me actually show you this graph first. This is what the graph is going to look like. It's actually horizontal stretch. It might look like vertical stretch in this case as well, but it's actually using this notation f of 2x, we would say this is horizontal stretch. Focus on this part. Let's try to understand this. What exactly is happening? You have one function f of x and you have one function f of 2x. So again, using the same logic as before, if you had one point x equal to 1, if you had some value at x equal to 1, that will give you f of 1. How would you get f of 1 from the second function now? What value of x would you have to input there to get f of 1? What value of x do we have to input here? We have to input x equal to 1/2. So the point that we were getting at x equals 1 earlier, now we get that same point when x equals 1/2. So you can see on the graph, the point that we had at x equal to 1 earlier, that moves to x equals 1/2. Similarly, the value that we were getting perhaps at x equals 3 earlier, which was f of 3, where will we get that value now in the second function? What value of x do we have to input here to get f of 3? We would have to input x equal to 1.5. So the point at 3 moves to 1.5. So this point at x equals 3, this moves to x equals 1.5. So basically, each x coordinate is divided by 2. We are multiplying by x inside, multiplying x by 2 inside. What happens to the x coordinate is it gets divided by 2. It's the other way around like this. Okay. So that's what happens in horizontal transformations. Let me now summarize all of this. Horizontal transformations. So you have movement horizontally. So you could have something like this. You could have something being added or subtracting inside. You could have something being multiplied inside. You could have a negative sign multiplying inside, right? You could have these three different cases. Now, if I were to write them all together, these are three things that can happen. Something happens inside the function. It could either be a multiplication with negative, it could be a multiplication by a number, or it could be something added or subtracted like this. These are three things that can happen. All right. Now, just to save time, I'm going to summarize this quickly by just copying all of that, changing that slightly. Now, just give me a second. I'll just correct this. Okay, good. Let's have a look at this now. F of minus ax plus minus b. So these are three things that can happen. You can either multiply by a negative sign. That's one possibility, right? Multiply by the negative sign. In that case, you say it's a horizontal reflection. So anything that happens inside the function, anything that changes to x, we say that's horizontal. So that's horizontal reflection. So let's say it's a reflection with y-axis as the line of reflection. If you have a point xy, where does that go? That goes to minus xy. Remember, only the x coordinates change in this case. The y coordinates do not change. So in this case, x goes to minus x, y coordinate remains the same. And then if you multiply by a number inside, what happens in that case? You say it's a vertical stretch. That's one way to describe, horizontal stretch, It's a horizontal stretch. That's one way to describe this. With scale factor, if this number is a, the scale factor is going to be reciprocal of that. It's going to be 1 over a. All right, scale factor is 1 over a. So if you have a point xy, that's going to go to 1 over a multiplied by x, or you could say x over a, and the y coordinate remains the same. So the x coordinate is going to be divided by that number, okay? Instead of horizontal stretch, you could also describe it as stretch along x-axis, or you could say stretch parallel to x-axis. That are alternative descriptions of this thing. That is also possible. Make sense? And then finally, you have translation. If you add or subtract something plus minus b, what happens is translation, only the x coordinates change. So y component of this is going to be 0. What about the x component? It's going to be minus plus b. Now I've changed the order, you can see. It was plus minus, I'm writing minus plus here. What that means is, if there was a plus sign here, that would mean the graph is moving to the left. If it was a negative sign here, it would mean the graph is moving to the right. Let me give you an example. Let's say you have f of x, and that goes to f of x plus 4. The translation vector for this, what is that going to be? You would say this is a translation minus 4, 0, right? It's 4 units left. So plus 4 here, and the function would mean in the vector you've got minus 4, because minus 4 in the vector would mean 4 units to the left. So it has to be 4 units to the left. That's how you would write this translation. If it was x minus something, you would have a plus sign here in the vector. Make sense? So that's why I've changed the order here. Right? If you have a plus here in the vector, you have minus. If you have a minus here in the vector, you've got plus. Okay. And similarly, if you have XY point, where does that go? X coordinate changes to X minus plus B, and the Y coordinate remains the same. These are the three horizontal transformations you could have. Any problem with this? Any questions, anyone?
No, sir.
No? Okay, just give me a minute. I'm going to leave a message in the other group quickly. All right, good. So that's what happens when we do transformations. We have some vertical transformations, some horizontal transformations. This is what you need to remember now. Now, remember, whenever you have something being added or subtracted, what does that mean? That's a translation. When you have something being multiplied or divided, when you have a number multiplied or divided, multiply or divide by a number, what happens in that case? You have a stretch. And then if you have multiplication by a negative sign, in that case, you have reflection. These are three transformations. Plus minus means reflection. Plus minus means translation. Multiplication by a number means stretch, and multiplication by negative sign means reflection. All right. And then we talked about horizontal transformation is when something changes inside the function. Vertical transformation is when something changes outside the function. Okay. So these are three different transformations that you can have, either vertical or horizontal. Okay. Now we're running out of time, but what I want to do is I actually want to, in fact, we'll do that in the next class then. We want to talk about order of transformations quickly as well. But what we can do is we can do that tomorrow along with the practice questions that I'll be asking you to do. So what I'm going to do now is I'm going to post some questions on the OneNote notebook. So in this notebook, I'm going to add some questions. And I would expect you to attempt them for tomorrow. We will be practicing those questions tomorrow. They're from recent past papers. And along with that, we will be discussing the order of transformations as well. For instance, what we want to talk about is, if we have a function f of x and it goes to f of x plus 3, this is kind of obvious that, okay, the function, there's a translation, horizontal translation, 3 units to the left. But what if you had something like this? If you had a function f of x and that goes to maybe 4 into f of x plus 3 minus 7, if you have something like this. Now, how do you know what transformation is happening first? What is happening second? How do you decide that order, right? We have three transformations. We have a stretch, vertical stretch. We have a vertical translation. We have a horizontal translation. How do we decide what to do first, what to do second, what to do third, right? The order of transformations. That's what we want to discuss tomorrow, along with practice questions from past papers. And then we'll be done with this topic. I'm going to add some questions to this notebook. Please have a look at them. I'll try if I can share them on the WhatsApp group as well. But I can't promise that, but I will definitely add them to this OneNote notebook. All of you have access to the notebook, right? You have the OneNote app downloaded. Is that correct?
Yes, sir.
Right. So the notes should be updating on your end. Once I add the questions, you can have a look at them. They're like 4 or 5 questions. I would expect you to attempt them before the next class. Okay. And then we'll discuss them. So that's it for today. I'll see you again in the next session. Those of you who are on YouTube, just a reminder, I have my past paper session starting from 13th of April, P1, P3, M1, and S1. The registration link is there in the description of this video, and also it's there in the live chat on the right side. The early bird discount is ending on 5th of April. There's like 3 more days left for that. You can have a look at the registration form. You'll find all the details there. I'll also be adding some more details on my Instagram and YouTube at some point today, explaining the number of years of past papers we will be doing, how the classes are going to be like, the size of the classes, how you can interact in these classes as well. So all of those questions that I've been getting, I'll be answering them in a few posts at some point today, inshallah. So you can have a look at them if you have any confusion, and also leave me any message on WhatsApp or Instagram if you have any confusion. But the rest of the details will be available there. All right, so I'll hopefully see some of you there. Until then, Allah Hafiz. I'll see you in the next class. How do you do this?